So, hello everyone, and thanks for joining. So, today we'll be talking about Python for data quality in 2025 and why tests actually no longer enough. It's not a mistake that it's in 2025 because currently we're in 2026, but end of the past year, I just stopped with all these ideas, changes because AI, a lot of stuff is going to change and so on. The main idea of today's topic is about data quality. I'm kind of expert in data quality, not an expert in Python, maybe, so sorry for Python conference here. And before we will start, definitely a few words about myself. My main role is lead data quality engineer, and I'm also head of data quality at EPAM Baltics, kinda engineer manager with 20 plus people in my pool, and I'm with EPAM since July of 2019, around 7 years, and it's a really beautiful journey. Maybe I would like to say about technologies, which is definitely cloud, Databricks, Palantir, Azure, and all of this stuff. But my favorite is actually reinsurance business domain because 6 or 7 years I'm working on this stuff. It's amazing experience, and I'm really considering some kind of educational in this one because I still I don't know a lot of things in data about this one. Definitely, I have to say a few words about EPAM, why I'm here. Beautiful company. As you can see, in a lot of countries, we have 60,000 plus people. We are like in data, cloud, a lot of different stuff. And also, we're constantly growing because, and here you can see that data is end of fourth quarter 2025, but I think that we are increasing a lot. About what will we talking today? So we'll start with just a brief overview of data quality, how it evolved during past years, why classical tests via Python is no longer enough, how we can apply some kind of modern data quality stuff with Python, what is the main engineering patterns, best practices, and I will finalize with some kind of conclusion and takeaways, motivate you maybe a little bit. And I definitely must say a few words about AI. This picture is generated by Alexander, who is sitting somewhere there. I cannot see him in the moment. But it's actual situation for the past like year or two, to be honest. AI is amazing, AI is good, but I'm not an amazing innovator, to be honest, because I like the classical things that are stable, that are working, and all the stuff. But what I'm leading that AI is definitely an amazing thing, but it's still based on the data. So what you're feeding into AI, and based on this, it will give you some kind of prediction, analysis, and so on. It is a lot of points written here, but the main thing is that, again, poor data has consequences, a lot of this stuff. And before we'll proceed about like main points, definitely what is actual data quality? So maybe you can raise your hands who understand it on like quite good level. No one? Five? Okay. You're too shy, I guess, because you're definitely working with this every day. So I could speak for several hours about that. Okay, we have data quality. Data quality is part of data governance. Data governance is part of data management. Sometimes data management is part of data governance, and so on and so on. Let's not overcomplicate these things too much. Long story short, let's not focus on the picture on the right too much, because this is just to show how overcomplicated things sometimes could be. Basically, the main idea is that when you're feeding garbage into the system, you have garbage out. And the more poor data you will have into your system, for example, if you have incorrect number of your package, then the courier just will not deliver. And consider how it could be scaled on the level of organizations. And when we're talking about like big companies, data companies, it's definitely a lot of data. And one more question about the data quality dimensions. So what is data quality dimensions? It's some kind of list which you could include and cover all of them. And basically, when you're covering all of the data quality dimensions, you're confident that, okay, we can trust this data, it's perfect, it's good for 100%. Maybe you have some ideas from 1 to 0? Anyone? Six. Guys, you're amazing. It's actually six, yes. But on the top, you can see that sometimes it could be four, sometimes it could be five, sometimes it could be seven, and so on. And within EPAM, data quality is really young discipline, to be honest, and it's only around 6 or 7 years. And in a lot of sources, you could read that sometimes it's 9, and so on and so on. Now, what is the main idea here? We agreed that it's 6, and the market globally agreed that it's 6. I am not saying that it couldn't be any kind of other variations, but when you are making sure that, okay, 6 is enough, and colleagues from other department, other managers will agree that, okay, it's 6, you're like in sync, and you can trust your data fully. Going briefly through each of them. Timeliness, okay, data is arriving when it's necessary. Consistency, data is consistent in all of the sources. So for example, like, I don't know, your passport number and actually passport number within some kind of system, that data is complete, that you don't have any kind of duplicate, so it is not another person with your name and Asmen Skoros in the city, and that the data is actually accurate. So basically that it's representing the real world for 100%. And the last one is validity. It's basically sharing the same format. As a good example, that in Lithuania we should use like +370, and so plus without any kind of square brackets and all of this stuff. And previously you could also use 8 before the phone number, if I'm not mistaken, but currently it's deprecated. And finalizing this one, so data quality based on like 5 points, starting from business, going through a lot of stages into technology. Again, here just an overview. That's the main idea, that first we need to understand why we're doing this, why it is expected for the business, why we require this to be, what we're basically doing, and only after this we're like communicating, building some processes, and implementing technology. Implementing technology is super simple, to be honest, because you know, then when you have good specification, it's easy to implement. If you don't know something to do, it's super complex. So sorry for some kind of retro, and how it's actually evolved during past years. Here again, I'm not saying that in 2023, 2024 it was like this, and boom, something happened, and starting from 2025 we're having totally different approaches. No. Again, from company to company. In startups, it's better. In some kind of big companies, it's definitely slower due to processes. But the main idea is that the data actually changed. And previously, it was batches, it was classical test, it was manual monitoring, it was a lot of limitations due to this one. Batches is probably my favorite one, because how it was previously, you had ETL process, it is executing daily, and at the morning you are opening like your automation report and seeing that, okay, data is good or not bad, and so on. And quality is being checked only after this point. The second point is classical test, basically is continuation of the first one, so the checks are super simple. Junior data quality engineer could go to any kind of project and create thousands of these simple data quality checks that, okay, we don't have nulls, that data is an expected like format from general point of view, that you don't have age less than 0 or more than like 150, which is super simple. But it's definitely not enough when we are talking about actual business meaning of this data, and reinsurance is probably the best example here. And talking about manual monitoring, I already partially covered this one, because again, we are checking the issue after. And due to this, we have some kind of snowball of issues. Then we have issues in data. We will know about this later due to batches. That's rules to check are super simple, and so on. What actually changed? Nothing and all at the same time, because shift to streaming and microservices are just growing, growing, and growing. And in 2025, I really noticed incredible amount of like projects, incredible amount like companies who are fully or partially moving this one. And especially this definitely speeded up with artificial intelligence, because yeah, and data is now flowing consistently. What it changed? We generally not allowed to have this data, this bad data in the target, because in this case we will spend a lot of time on some kind of analysis, fixing root cause and all the stuff. And it's not only about the data that we need to verify in streaming processes. It also changing of the data formats and schema itself. So, okay, you have like table or CSV file. It's coming, it's table, column edit, removed, super simple. But what if you will have super complex, you're welcome, I can wait. When we are talking about complex JSON, XML files, addition of nested interactions and all the stuff, and even with AI, more complex data structures, it's not so simple. And we need some kind of dynamic, we need some kind of adjusted in real time pipelines that will actually handle this data. Business is also moving because we have new streaming data, and definitely business is not okay that okay we will have data after the 3 quarters which was reflected your sales across the previous year and so on. They are not satisfied with this one anymore. They would like to have quicker decisions, and again it's related to that the data must be trusted consistently. What from technical perspective, finalizing this point? So we need to check data now, we need to check data proactively, definitely not reactively, and also we need to add this data quality checks into orchestrators, into pipelines, and in the end of this presentation we'll discuss several tools on the high level. And ideally, what business and projects is always expecting, but sometimes it is not working, that we don't have just alarm that something has happened. We will have an actual automatical system that will fix everything without any kind of issues. So why tests no longer enough? Already covered this point on a high level, but as an example, you can take a look at this beautiful picture. If you worked with automation with Python or any kind of another programming language on the dataset, static dataset, or even like with the web application, doesn't matter. You're already familiar with this one. So table, test name, some categories, failed or not failed, and so on. But again, only about high-level issues. And it is not including business context. It is not including some kind of business domain knowledges. And what is the main problem? That if we have some complex cases, data spikes, fully no data, which will lead to false positive tests and so on, it will be a surprise to the team. So as a summary of this one, what is actually missing? When the data will arrive late, tests will still pass, but issues will be discovered later. Data management is always a problem with all of these columns, all of the stuff, especially with XMLs, JSONs. Just test didn't remove this one, and we need to rely for other teams in this point. Drop or spike in data volume is major issue from my point of view, and it's especially clearly seen during some kind of Black Friday sales or January, this end of December. So in this case, when we're talking about New Year and Christmas, it's expected, but usually business is just ignoring when, okay, something is happening during the middle of the year and so on. And sometimes it's mostly related to issues in the data, not to just increasing amount of sales. And okay, from the technical point of view, data is okay, but business meaning of this one changed a lot. This is leading to a lot of consequences, and if you're a fan of John Wick series, you definitely know what is this one and to what it could actually lead. And summarized it is a table. Not going to discuss this too much at the moment, but the main idea is what we can do. What switch between classical test and manual monitoring. So we need to do it all of the times. We need to be aware about the data context and unexpected changes. All of the times we need to do everything automatically. What's the Python role in this one? So this will be covered in modern data quality key practices with Python, but considering that I see some bored faces already, some fun fact. You can see beautiful guy It's free driver, Vitamin Marichicic. I hope I pronounced it correctly. And he actually holds his breath underwater for quite a long period of time. How do you think how it was in minutes? Super optimistic. Okay, it's less. Not 5, not 10. Okay, 29. And I don't know how. I can do it for 30 seconds, to be honest. And why I am leading this one, not just to catch your attention one more time, but sorry, one more joke. Definitely don't try this at home due to this. Yeah. And previous record was around 24 minutes, and it was established like 1 or 2 years due to this. But why I'm highlighting this example? Because it's actually a current Guinness World Record. And if I just said that, okay, guys, someone holds their breath for 29 minutes, you're like, okay, haha, Artem, good joke, where are the proofs? When I'm saying like it's Guinness record, you're like, okay, it's proven. I can trust you in this case, or I can go in some kind of place and actually verify that we have some kind of video recordings, we can all of the stuff and so on. So you are trusting the data in this case. And it's a very good example why data is super important and good quality of data especially. So coming back to the Python, coming back to the tools and so on. So data, as I mentioned, the main four problems is freshness, it's anomaly detection, it's schema changes and all of the stuff. We can proceed with two different ways here, and with Python and with integration something into external tools or clouds like AWS or Google Cloud or something similar. I'm really would like not to say this one, but unfortunately Python checks is really not working well. Why? Because simple Python when established like locally or within your cloud instance and so on without integration in tools, it is causing the main problem that you will be checking the data after. So the data will load, only after this you will execute checks. Or you will need to create some external additional dependencies. And for example, talking about data freshness and completeness checks, you can add some kind of function where you will be passing that, okay, it's when the data frame refreshed, when it was refreshed previously. But why we have to do this one if, for example, we have Databricks Data Lake where it is already integrated and you could do this via user interface, or you could do this simply via adjusting some kind of code. And it is even scaling more when we're talking about more complex issues like volume anomaly detection and distribution drift. The things that I mentioned about spikes during Christmas period of time, during other periods of time. So again, you can write some kind of, okay, this is the current amount of the data, this is how the data is usually adding for this period of year via the Python, but again, this will be executed after or with some kind of customization. Or you can just go Great Expectations, Monte Carlo, evidently AI. Talking about the last one, I didn't work with this one, so I'm not committing his error, sorry. And it will be integrated there. The same goes with version data contracts and schema evolution. And I'm really glad that I'm working in the time when we have such data governance, data management solutions like Databricks Unity Catalog, for example. Or within the Palantir, we have this beautiful data lineage where you're having the data in the source and you can track it through the several transformations, several layers, thousands, okay, not thousands, but I don't know, up to 50 data sets, probably my worst example, and it's again. And it is being actually integrated, and I'm really encouraging to use some kind of already created tools for this one. But my favorite example here is related to Apache Airflow. You can do something similar like Dagster and so on, but again, unfortunately, sometimes it's not to us. Sometimes it is already established on the project and we have to do something. But from my experience, Apache Airflow and its DAGs have an amazing opportunity to work with Python directly within DAGs. And with this Python code, you're basically setting a hard line that, okay, if bad data is even trying to get into the system, you're writing it in some kind of error table, or you're just saying halt to this pipeline, and it's actually being stopped. I understand that it's really sounding like a silly and stupid idea, to be honest, but sometimes we really don't need to reinvent the wheel when everything is being presented already. And last 5 minutes I would like to allocate to some kind of call of actions and summarize these best practices. And again, it's only from my point of view. Sometimes it could work, sometimes it could be not working, but I did a lot of mistakes working with data quality, and better to learn on my mistakes, not to create your own, to be honest. Discussed it several times, and one more time, do data testing before the data will flow into your table. I met really a lot of cases when people allowing this to do and spending not only your capacity, not only team capacity, not only business capacity to revert this one. It worked previously. It really worked when you have batches. You can just, do some kind of backup restoration, and everything will be good. It's not working with streaming. Do not automate everything, even with AI. It's really complex point, to be honest, because I really know that each of you have some kind of great experience when you wrote your first Python or any kind of other programming language function, which was receiving to integer, which was like returning some of this integer, and it was super motivating, at least for me, and I think you have similar examples. And this is what actually doing us engineers. That's why we have passion to this one. But sometimes automation is really, really bad. It is a lot of cases when you are just trying to automate everything, but you spend 10, 20 hours automation, which you can do simply doing 5 minutes, even with AI. Yes, especially for you. And talking about monitoring only what matters. So, when I was going to this conference, I was talking not about the data quality, not about the Python, but about the amount of the data that we are currently receiving. Because again, market is evolving. We have a lot of stuff coming. We have like IT news. We have some kind of new frameworks, new ChatGPT models, and all the stuff. And our brain is super cool, but unfortunately, even our brain have some kind of limits. And this is superly clearly shown with this AI evolution and all the stuff. And the same applies to data quality. And my best example is probably when I worked on one project. We have a simple txt file with configuration, which was loading. And it was around like 140 or 50 checks on this one. The file was loading for years, and none of this check even failed, and it wasn't an important functionality. Was this necessary? No. Was it cool? Probably yes, but I don't see any kind of point in this monitoring and automation, to be honest. Again, it's super simple, but we need to collaborate. That's why we're here. That's why we're not just reading some kind of articles in the internet, but again, data projects is not small companies. It's not like because small companies will not just have the necessary amount of the data. I met a lot of cases when the upstream data changed because the data warehouse team did something in their, like, again, data warehouse based on Oracle. Everything is broken on our side. We're humans. We need to speak. We need to collaborate, and collaborate to make this happen. As a continuation on automation, a little bit contradicting with this one, but still better to create 5 proofs of concepts and 1 solution better than if you will not create any kind of proof of concept, but you will create 5 solutions. Again, it is easier when you're working on a big project because everything established and you can reuse some existing infrastructure. But when the project is just starting and you have a variety of technologies, think about this one, please. Visualization of data quality. To be honest, I don't like visualization. When I was studying in EPAM data campus, like Power BI and Tableau were the worst models for me because I don't like these graphs and so on and so on. But I really must admit that it's working for a lot of people, especially with the business. And that's how it's unfortunately working. If you wouldn't like to do this on your own, like me, delegate to something, but this visualization and graph and data quality dashboards, they're working just amazing. And just a couple more points that connected to root cause analysis that I already mentioned. So fail is super fast. Your pipeline failed, someone escalated, you fixed it in 30 minutes, 60 minutes, 2 hours, everything is cool. If the data in your system, if its system doesn't have reliable backup or this backup will break a lot of other necessary stuff, well, in this case, you're really in a kind of big problem. Data shouldn't reach your system. Bad data shouldn't reach your system. And basically the main idea of what I trying to share today, the streaming and similar stuff is increasing everywhere. And yes, it's not just started, but finally it is being applied to business quite a lot. And yeah, just don't allow the bad data to propagate. I understand that it's super easier speak than done because again, we have deadlines, we have priorities, we have super important stuff, but this will save you time. I would like to finish my speech with this kind of positive picture. So why was the snowball fight cancelled? Because it was too much chill in there. I would like to say it in some kind of format that if you will not have any kind of bad data in your final system, in this case you will just don't have any kind of problems to fight. Everything will be chill, everything will be good. So please think about the data quality, and thanks a lot for joining.